Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability in exercise 5.4 7 sum. Differentiate the following with respect to x. So here given square root of e power root x. This has to be differentiated with respect to x. And the condition of x also we have x is greater than 0. So here the given function I am going to name it as a y. So let y equal to square root of e power root x. Okay, and we know that square root is what? Basically it's a power 1 by 2, no? Power 1 by 2 only we have a symbol to use the square root. Okay, so I'm going to rewrite the square root as a power 1 by 2. Okay, so e power x power 1 by 2, and outside we have square root, no? So that one overall power 1 by 2. So for our convenience, I just rewritten power as a 1 by 2. Now let's do the differentiation. Is it in a standard form? The given function is not in a standard form. So first what we need to do is power we have to do the differentiation, treating the entire inside the bracket, no, the entire thing as a treating at a x. Okay, just treat it as a x. With the help of x power n formula, we have to do the differentiation. So first what we are going to do, power we have to do the differentiation. After that exponential function we are going to do the differentiation. After that this power, this x power 1 by 2, we are going to do the differentiation. So chain rule. While writing in the chain rule, after differentiating the every part, we have to write only in the product forms. Okay, so first power I am going to do the differentiation. So differentiating with respect to x. So this side if you differentiate, it's a dy by dx. Okay, so treating the inside the bracket everything as a x. Okay, we are not going to disturb here. So only power we are going to do the differentiation. And differentiating the power, what is the concept here? The power we have to bring it as a coefficient, then we have to reduce 1 to the power. So what is the power here? 1 by 2, no? So 1 by 2 bringing it as a coefficient. Inside stuff will be there as it is. Then reducing, already existing power is 1 by 2, no? So reducing 1 to the power. With this, power differentiation is done. Okay, next e power x power 1 by 2 differentiation we have to do. Is it e power x power 1 by 2 is a standard form? No. So only we have exponential function e power x alone we have. So e power x differentiation is what? E power x, no? Then e power x power 1 by 2 differentiation is what? Same, e power x power 1 by 2. No change in that. Okay, with this exponential function differentiation is done. Okay, now into, so I already told you that we have to write only in the product forms. Now x power 1 by 2 differentiation we have to do. So that is x power n formula we have to use. So what we need to do, power we have to bring it as a coefficient, then reduce 1 to the power. Then now x differentiation is what? X differentiation with respect to is dx by dx. No need to write, which is 1, no? With the 1 if you multiply anything, the same thing. So no need to mention that. Okay, so what we have done here, first we differentiated the power. Okay, so on differentiating the power, we got this term. Then exponential function, we done the differentiation. Exponential function differentiation is exponential, same thing only will get. Okay, then x power 1 by 2 differentiation, this part. Okay, and always we need to write only in the product forms. Okay, so that's all, differentiation is done. Now we need to do the simplification. So 1 by 2, we know that power 1 by 2 shall we rewrite as a root itself. So e power root x. Okay, now 1 by 2 minus 1 is what? From 1 half if you subtract, half will be there. So since 1 has a negative sign, minus half, minus 1 by 2. And here again x power 1 by 2 we have, no, I'll write it as a root x. Now we have 1 by 2 here, x power 1 by 2 minus 1 is what? Minus half will be there. Okay, and this one, since it has a negative sign, we can take it to the denominator. Okay, and 1 by 2 we can write it as a 1 by 4, and in the numerator only e power root x will be there. Okay, so e power root x whole divided by, okay, 2 into 2 4. Okay, now since it has a negative sign, I'm going to write it in the denominator. Okay, so e power root x whole power positive 1 by 2. Since we brought it to the denominator, sign will change, negative to positive. Same way here, x power minus 1 by 2, no? So this we can write it as a x power 1 by 2. Now if power 1 by 2, we can rewrite it as a root. So e power root x whole divided by 4 e power root x square root. Okay, now root x. Okay, so that's all. And here if you notice, this e power root x is what? Basically it's a 1, right? So this can be, suppose if it is 2, 2 can be rewritten as a root 2 into root 2. This way we can write, no? So same way, what I am going to do is e power root x, I can rewrite it as e power square root of e power root x into square root of e power root x. This way we can rewrite, no? Yes. Now whole divided by 4 into square root of e power root x into root x. Now 1 time of square root of e power root x, square root of e power root x will get cancelled. Now what is the left out term? Square root of e power root x by 4 root x. Okay, so that's all, the solution. And if you want, here itself also we can do that. So what is this? It's a whole power 1, no? If base same, we can add the powers. So even in this step itself, we can able to simplify that. Okay, so either way we can do, whichever is convenient, you can follow that. Okay, so that's all the solution for this. Thank you for watching, and please do subscribe. Okay, thank you.